Okay, welcome back to trigonometry. We are continuing on our identities crusade here. So we have cotangent squared of A, or alpha, divided by 1 plus cosecant A equals 1 minus sine A over sine A. Now, in this one, yes, we could actually start thinking about what to do with the right-hand side, but usually, if you don't know what to do, start with the left. It's usually the way these things are set up. So the way I'm going to start this one is say we have sine squared plus cosine squared is equal to 1. I'm going to divide everybody by sine squared. Okay. So we end up with a 1 plus cotangent squared is equal to cosecant squared. Okay. So what I'm going to say here is that cotangent squared A equals cosecant squared A. I'm going to subtract 1 from both sides, minus 1. Okay. So here we have my first move here is to say this is 1 minus cosecant squared A. I'm sorry, no, I'm not going to say that. I'm going to say cosecant squared A minus 1. Okay, we have cosecant squared minus 1. And then here on the top, we have cosecant A plus 1. And we have 1 minus sine A over sine of A. Okay, we're just going to hold this off to the side. Again, we can't cross the streams. You're not solving anything. We're not, it's not an algebraic equation. That's a conditional statement, like 3x minus 5 equals 13 or something. That's a conditional problem. This is not these are not conditions. These are identities. So these are some things that should always be true or they're false. Your book doesn't lie to you, so these will be true statements. So we're trying to prove this to show that this is what's true. So we're going to say difference of squares here. So we have cosecant of A minus 1, cosecant of A plus 1 divided by, and here we have on the bottom, we can swap the order, cosecant of A plus 1 is equal to, here we have 1 minus sine A over sine A. We're going to leave that alone. All right, well, we'll see what happens. So these guys can cancel. So I've got cosecant A minus 1, okay, and we'll see what happens with this. So the other way to write cosecant is to say this is 1 over sine A minus 1, and we'll see where I get with this thing. So at this point, like I would really love to get common denominators here. So I'm going to take this as a sine over sine A. So 1 is really sine A over sine A. So I've got 1 over sine A minus sine A over sine A. We can go ahead and combine fractions now. So I have 1 minus sine A here over sine A. And let me go peek and see what the answer is supposed to be. Oh, it's supposed to be this. Okay, we're all set and done. That's an identity that's sorted out. Okay, let's look at the next one. I'm going to write it down and we'll go ahead and prove this one. Okay, so we'll go ahead. We'll say, okay, which one was this? That was D. So this part is E. So I have sine of 2 beta plus cosine of 2 beta. So here we have 1 plus sine of 2 beta plus cosine of 2 beta. Okay, let's go ahead and double check this. Divided by cosine beta plus, or sine beta plus cosine beta. Sine beta plus cosine beta is equal to, let's see what we have here. We have, this is equal to 2 cosine betas. It's 2 cosine beta. All right. Now, for this problem, looks like we have some double angle formulas to figure out here. So we have 1 plus sine of 2 beta is 2 sine beta, cosine beta. That's just the double angle formula. Plus, now for cosine of 2 beta, we got a lot of choices. And we could say it's going to be something complete with cosine squareds in it, something complete with sine squareds in it, something with sines and cosines in it. I'm looking at the right-hand side here. I'm thinking, I got some cosines over there. I think I would really like to have some cosines over on the right-hand or left-hand side here. So what I'm going to do is I'm going to say this is 2 cosine squared beta minus 1, and we still have our fraction here, sine beta plus cosine beta, and we'll see what this equals here. All right. So what are we doing next? We have this one and this one. These are going to cancel. So I have 2 sine beta cosine beta plus 2 cosine beta divided by sine beta plus cosine beta. I'm going to go ahead and factor out a 2 cosine beta out of this. This is a squared here. I'm going to factor out a 2 cosine beta out, or out of the top here. So I'm going to say this is 2 cosine beta times what? We have sine beta plus cosine beta. Divided by it, we have sine beta plus cosine beta. Hey, some stuff cancels, and we end up with 2 cosine beta, right? And that was what we had to prove. So we're all set and done with this one, okay? So this one's a little tricky because you have to choose your cosines and like decide which one you're going to like. You're not always going to pick the right one. Like if this didn't end up going where I wanted it to go, the place I would return to would be that point right there because there's 3 different options. Maybe one of the other options works better. I don't know. So if I got stuck somewhere, this is where to return to see if I could figure out what's going to happen from here. Okay. So that's the kind of thing you're looking for. All right. So that one's kind of tough. Let's see. We have a sine of a plus b over. Let's go ahead. Writing this one down is going to be the hardest part of this thing. So we have sine of a plus b divided by, let's see what we have here. Sine of a plus b, cosine a cosine b. Cosine a cosine b is equal to, what are they saying? What are they claiming here? Is equal to tan a plus tan b. Tan a plus tan b. Okay, sine of a plus b. That's one of the things we have to deal with. So we're going to unravel this. So we have sine, cosine. So sine, cosine plus cosine A, cosine B. Sine, cosine, cosine, sine. Okay, that's how those things work. Divided by, I've got a cosine of A, I've got a cosine of B here. Okay, so we have a fraction here. So this is sine. This is supposed to be a cosine. That's a terribly written cosine. Let's go ahead and fix all of that. So you can see what I'm doing. Sine, cosine, cosine, sine. Okay. So sine, cosine, cosine, sine. Yes. All right. Now we're going to see if we can't break these things up. So what I'm really going to do is I'm going to say this is sine A cosine B over cosine A cosine B plus cosine A sine B divided by cosine A cosine B. Well, some of these line up pretty nicely, right? We have a cosine over a cosine, those cancel. We have a cosine B over cosine B here, or cosine A, so this cancels. So let's see what we have left. We have a sine A over a cosine A divided by a sine B over a cosine B. That's equal to tangent of A plus tangent of B. I'm feeling pretty happy about that. That is exactly how that's supposed to work out. So it's pretty much just asking you, did you remember your sum of angles formula? That's really all it's asking you for that one. So let's see. I think we're going to call it quits on this one. So we could say we did B, we had D, E, and F on this one. Okay, so I'm going to say thank you very much for watching the video. We'll see you in the next one. Practice your identities and good luck. All right, take care.